Good morning to everyone. I'm Dr. Sumi MS. The name of the course is Electromagnetic Fields, and today's lecture topic is Electric Fields and Electric Flux Density from Unit 2 Electrostatics. On completion, the students will be able to understand the representation of electric field and describe about electric flux density. Electric field. Electric field E is defined as the force that is acting on a test particle divided by the charge of that test particle. Here E is the electric field, which is given as F divided by Q naught, where Q naught is the charge under test particle. We shall also represent electric field from a single charge as E is equal to 1 by 4 pi epsilon naught into Q by modulus of R square into R cap. This diagram represents the electric field on a single charge. Charged particles in electric field using the field to determine the force can be represented as F is equal to Q times E. Electric field as a vector field. The electric field is one example of a vector field. A field, either vector or scalar, is defined everywhere. A vector field has direction as well as size, and it is represented in units of Newton per Coulomb. Representation of electric field. It would be difficult to represent the electric field by drawing vectors whose direction was the direction of the field and whose length was the size of the field everywhere. Instead, we shall choose to represent the electric field with lines whose direction indicates the direction of the field, and as we move away from the charge, the density of the lines decreases. These are called as electric field lines. Drawing electric field lines. The lines must begin on positive charges and these lines must end on negative charges. The number of lines leaving a positive charge or approaching towards a negative charge is proportional to the magnitude of the charge. Electric field lines cannot be represented in a cross manner. These are certain diagrams representing electric field lines. Here we shall see electric field lines from a conductor. Electric flux density. Electric field intensity, or simply electric field, gives the strength of the field at a particular point. The electric field depends on the material media in which the field is being considered. The flux density vector is defined to be independent of the material media. For a linear isotropic medium under consideration, the flux density vector is given as surface integral over d, and here d is represented as Z times field E. Quiz questions on electric fields and electric flux density. How do you represent electric field of a single charge? What are electric field lines? What do you mean by electric flux density? Thank you.